Today's question is to compute the integral e to the power of z squared over z minus 2 dz, where the contour c is the curve shown below. So from this given function, in the denominator part we have z minus 2, and also in the curve we know the point 2, 0 is within this given contour. So now we should know that we're going to use this theorem when we learn the Cauchy's integral formula. So this theorem tells us that if f is analytic everywhere inside and on a simple closed contour C, taken in the positive sense, and if z0 is any point interior to this contour C, then we have this function f z0 equals 1 over 2 pi I times integral f z dz over z minus z0. So now let's compare the given function with the one in that theorem. So we know fz should be e to the power of z squared. And we know this function is analytic everywhere inside and on this given contour C. And from the denominator part, we know z0 in this case should be the point 2, 0. And this is also inside the contour C. So we know we can use the theorem to calculate. Okay, now let's rearrange this given formula. So we can have, if we move 2 pi I to the other side of this function, we have integral f z dz over z minus z0 equals 2 pi I times f z0. So let's just substitute fz over z minus z0 dz integral equals integral. Here fz is e to the power of z squared and z0 is 2. So based on the theorem, we know it should be equal to 2 pi I times f z0, and we just substitute z0, which is 2, into the fz function. So it becomes 2 pi I times e to the power of 2 squared. Therefore, the final answer is 2 pi I times e to the power of 4.